All right, ladies and gentlemen, today we are going to be taking a look at solving systems of equations, which means we have two equations. We want to see where they intersect or what values they have in common. So you should have seen things like this when you took Algebra 1 before. Graphing two lines, substitution, elimination, things like that. So we're going to go through a couple examples of each, kind of get you back into the swing of things, then we're going to start working on some story problems with these. So you have sheets in front of you already that have everything set for you, okay? Because at first I thought I wasn't going to be able to make a video, but now it looks like I am. So you'll notice in front of you, I've gone ahead and I've labeled the y-intercept and the slope for you and how these things would go. So I'm going to take a minute just to explain again how this works so you can visually see how it's going, and maybe you'll decide you want to write another note somewhere that might help out a little bit. So when I'm graphing, my y-intercept is always what I want to graph first on the y-axis. And then this value that's in front of x tells me the slope. Now, if there's a negative, I can't put the negative on both of these. I have to choose one. I normally just go ahead and put that negative on the top then for my slope. And again, this is my up or down, up top. So I'm going to go down 2. This is my left or right on the bottom. And since it's positive, I'm going to go right. So I'm going to go down 2 and right 3 until I run out of space. Okay? I'm just going to leave it as dots for right now. Then I'm going to move to my other equation. Do the same thing. My y-intercept is -4. I have to pay attention to the negative sign. And then if my slope isn't a fraction, I'm going to go ahead and make it 1 by putting it over 1. Then I can figure out my slope. Since it's positive, I'm going to go up 2. And since it's positive denominator, I'm going to go right 1. So up 2 and right 1. So I'm going to keep going up 2 and right 1. Ooh, winner, winner, chicken dinner. I'll come back to that in a minute. Then if I go to make my line, and again, it doesn't have to be perfect. If you want to use a straight edge piece of paper, if you got a ruler somewhere, that's cool. But here's our goal, right there. Where do they intersect? Well, what's the coordinates of that point? It's right, 1, 2, 3, and up, 1, 2. That's my answer. So anytime we're doing these, we've got to graph the line, and I've also put on my website a lesson on just working on graphing the lines and stuff in case you need some help there. -4 is my y-intercept, that first dot again, always on the y-axis. Put the negative up here. So I'm going to go down 1 and right 3. Now you may say, hey, I just ran out of room. Here's something I want you to consider though. If you do -1/3, okay, that'd be down 1 and right 3, like we just did. But I also can switch where the negative goes. I could put the negative on the bottom. So then I would go up 1 and left 3. And that lets me make an extra dot. And that may be the dot that I find is the intersection. So make as many dots as you could using both directions. Okay, here my y-intercept's at 4. Uh-oh, up 7. I'm supposed to be going up 7 and right 3, but I can't do that. Here's the other thing you can do. You remember when we've talked about, or you've heard in math class before, that two negatives make a positive? I can treat this like it's -7 over -3, because negative divided by negative would be the same thing. It would be positive like this is. So I can go down 7 and left 3. 1, 2, 3, 4, 5, 6, 7, 1, 2. See, there's that extra dot we made. It paid off. Because now we see where the intersection is going to be. So we have to be able to be flexible with these. And my point, again, we always do the x value first, then the y. Well, in this case, they're the same. But so that's how our graphing is going to go. If graphing's an issue, like I said, I have a video online that you can just look at some of the graphing and get some extra practice with this. And if we see it's an issue, we can take on some extra graphing a little bit later. So that's one way to solve our systems. Our next way is using substitution. Like you've got in your sheet, we're going to find the one that's already solved for a variable, in this case y. I'll plug that guy into the other equation in that y slot. Okay, so basically here's what I'm doing. I'm going to take that second equation, but when I get to the y, I'm going to replace the y with what's in the box. That's why it's called substitution. I'm substituting that value in. Now I just go ahead and simplify what I have. Oops, I got to finish the equation, don't I? So I'm going to distribute. I'm going to go ahead, and since they're on the same side of the equals, I'm going to combine my like terms. I'm going to go ahead and move up here. Notice I didn't do opposites since they're on the same side. Just -7 plus 9 is 2. And then I'm going to go ahead and solve the rest of this. I'm going to go ahead, minus my 24 from both sides. And divide by 2. Now, here's where I got to be careful. I'm not done. We're so used to, I got X, I got the answer, I'm done. Yeah, not quite. Almost, though. My last thing to do is, I know what X is, I want to know Y, but keep it simple. The one that's already solved for Y, that's where we're going to plug this in, because that makes this easy. So my last step is to plug this -2 in right there. So y equals 3, not x. I know what x is. It's -2. I just figured that part out. Plus 8. So -6 plus 8 is 2. I know we're a little cramped for space. And then normally, I wouldn't count this wrong if you didn't though. Normally we write the answer as a coordinate point then. Okay, and no, that's not the bell for you to ring. This is just the issues of me trying to do this during a prep period with all these bells. We're going to do the same thing on the next one, and again, you've already got the sheet to let you see how that works. Okay, so we just got to take our time and be careful a little bit. So that's how substitution works. Okay, elimination. And no, you're not every day going to be getting note sheets that are completely done. Like I said, just a video issue before, but we've got it taken care of. This is great. So solve by elimination. Multiply one of the equations by a value that makes a variable cancel out. Now, I won't always tell you whether it's going to be 1 or 2, but I thought on the notes it'd be nice. Well, how do you know, Mr. Harty? When I look at my equation, my goal is to either eliminate x or eliminate y by multiplying an equation. So I look and I'm like, okay, can I multiply 2 by something and get 10? Well, yeah, you can multiply it by 5. Okay. But if I just multiplied this top equation by 5, what would that get me? It'd get me 10x. Is 10 plus 10 eliminate? Well, no. Well, what's the opposite of 10x so it would eliminate? Well, it's -10. Okay, so if I want this to be -10, in this case, I need it to be a negative. Will it be every time? I don't know. So in this case, once I do that, let's see what happens. So that -5 multiplies all the way through here, distributes. So I get -10x, -35y, and negative times negative is a positive 130. Notice I'm not changing the bottom one at all this time. Because now when I go ahead and add them up, -10 and +10 cancel. That's the idea of elimination. I want to eliminate one of the variables, at least at the start here. Now I can just add down. So -26y is 156. I'll divide by that -26 and find out that y is -6. Cool. But again, like we did in the last one, I still got to know what x is. So I got one more step to go. You can pick either original equation to stick your y value into to figure out x. I normally just use the top one, just, I don't know, habit, I guess. So I'm going to use the top one. But again, when I get to y, I know what y is. It's -6. So the y goes out. Okay, it doesn't stay there. Don't make that 6y. The y comes out. And everything else stays the same. So the only thing that changed, I plugged in -6 where the y goes. Watch your signs still. Algebra is so detail-oriented. It's one of those things, even if you make a little boo-boo, it can kind of really screw things up. So you really got to take your time here. Work on getting my x term alone first. and divide. And I've got my answer. And no, there is not a shorter way to do it. Okay? Sometimes it is. It's going to something takes longer, but it's worth it in the end to get to a solution. Now you're like, well, what's the difference between that one and the one down here? Because it says I got to multiply both equations. Again, how do I know? Well, here's how you're going to figure this out. You notice, remember on the last one, we kind of talked about, well, 2 times what gets me to 10, and I kind of would look. Well, here's our issue. We always do smaller times larger. Can I multiply 3 by a whole number and get 4? No. I can do a decimal. I don't want to mess with a decimal. Can I multiply 6 by a whole number and get 8? Nope. Well, crap. Well, how do I do that then? Watch this. Check this out. This is slick. All we're going to do is we're going to take the numbers in front of the first one, and no, it's still not time to go. And we're just going to flip them. What do you mean? I'm going to take this, I'm going to make this 3. This one on the bottom, I'm going to use that 4, I'm going to make it 4. Sometimes I may have to throw a negative in, but I don't have to here. Why? This one's negative already. See, because then when I distribute through and I just switch those numbers around, I don't pay attention to the positive, negative unless I have to. And distribute through, check out what happens. Oops, got to be careful with my own signs here. By just switching those numbers and not doing one as a negative, one's positive, one's negative. If you do it that way sometime and they both end up positive, then you just slap a negative on one of them. We're flexible. So the x's cancel. Negative 24 minus another 24 does not cancel. It is Bell-O-Rama in here today.
Okay, apparently I'm an idiot and can't count.
All right, sorry for my little delay there. We had a visitor, Mrs. Osar, stopped in. Okay, back at it here. So we've got our y's by themselves. We're going to divide here, get our y value. Remember, got to have y and x on these. So step 2, similar to what we did up above. Plug that into either one of these. If you have a favorite, great. If not, I just keep using the top one. So 4x minus 8, don't put the y in there. We know what y is. It's negative 1. So we get to do elimination and substitution together. It's kind of cool. So negative times negative is positive. I'll minus my 8 over and divide by 2. And get to my solution. Okay, so you have lots of tools in your toolbox. If I didn't tell you what one to use and gave you a choice, you can do any of these. Okay, but I think I've done pretty good. I've told you basically which ones did you want to use on these to make this a little bit easier. Okay, so those are our basic forms. Now, oh, the dreaded story questions. You like my typo up here at the top? Only set up the system for equations for this section. That I should say of, but you get what I'm saying. So how do I do this? Okay, basically you're going to have 2 separate types of things going. First, we got to figure out what the variable terms are. So I start looking, I'm like, okay, senior class at high school A, rented and filled, 2 vans and 1 bus with 56 students. Okay. High school B, rented and filled 10 vans and 3 buses with 208 students. So it looks like my 2 variables here are going to be V for students in vans, and yes, you need to know what the variables stand for. That can really come in handy sometime. And then B will be students in buses. Because again, find what? The number of students in each. Not the number of vans, we already know that. The number of buses, we already know that. But we're just going to set up here. So here's how this is going to work. Okay, I got 2 vans plus 1 bus equals 56 students. And then I've got 10 vans plus 3 buses equals 208 students. And normally then I'd go through and solve it like we did that, but right now we're just working on some setup. We'll do a couple where we solve them. But that's how all of these are going to work up here. So again, I get a real similar one for the next one, actually for the next couple. Good job, Harty, on not varying this up very much. So I guess we'll just set up these first couple, and then I'll work down at the bottom with you a couple on figuring them out. But again, look for what you're looking for. How many students can a bus carry? How many students can a van carry? Okay. 10 vans and 7 buses. 3 vans and 6 buses. And just turn it into an equation. Vans plus buses equals total number of students. Vans plus buses equals total number of students. And that's all we're doing. Okay? The wording might change a little, but the setup doesn't. Okay? So I'm going to skip the next couple because, again, we can only do so much with vans and students here. Let's come down to the bottom. Okay? And I'm actually going to go down to number 12 because it gives us the most room to be able to work with here, and it's a little different. We finally get into something besides a bus and a van. What are we looking for this time? Ooh, how much cost? How much does a French silk cheesecake and a chocolate marble cheesecake cost? Okay, so we're gonna make F equal French, not sick, silk pies, and we will make C the number of chocolate marble pies. Okay, let's get down to business. Hong sold 11 French silk plus, that should say cost, bad Harty, 6 chocolate is $261. Okay, then for Julia, 6 French silk, 7 chocolate marble, $202. So now I got to figure out, okay, neither of them are solved for a variable, so substitution doesn't make much sense. Looks like we're going to do elimination. So if I'm going to do elimination, again, I got to go through and say, am I going to multiply one? Am I going to multiply both? I don't know. Can I multiply 6 by something to get 11? Because it's always smaller to bigger. Well, no, at least not a whole number. Can I multiply 6 by some whole number to get 7? No. So I got to do the old flipperoo. So remember, when we talked about doing the old flipperoo, we said, okay, we're just going to switch those around. But am I going to have to make one of them a negative? Well, are either of my original ones negative? No. So if I just multiplied now, a positive plus a positive, that doesn't cancel out. So I need one of them to be a negative. And it doesn't matter which one. Normally, I do the bottom one. I don't know why, just because I guess it makes me feel more like it's a minus or something. I don't know. But we've got to distribute through. So 66F, 36C. Okay, Harty is not this sharp yet this year. I am going to have to pull up the old handy-dandy calculator. And again, we'll talk when I get back about how you can actually upload this yourself and have this on your computer. It's kind of cool. So, without making too much more of a problem here, let's see. So I need 261 times 6. All right. So 1566, denominator, negative 66F, there's my cancel, minus 77C. Yeah, one more time to the calculator today. 202 times negative 11. Oh, twos. All right, so negative 2222. All right, let's see what we got here. Add down, goodbye F's. Negative 41C. Oh, I got the calculator away a little too quickly there. If I can get it back up, there we go. So 1566 minus, twos are wild. I don't think so. I don't think I was hitting 3. 5? What? Technology is great till it has a mind of its own. Okay. There we go. Negative 656. I know here I have to divide because I'm multiplying by 41, not dividing. So let's see here. Divide by negative 41. No. This calculator, holy cow. There it is. All right. So, $16 for a chocolate cheesecake. Am I done? No. We know better than that. Swing over here a bit. I know that I still need to go back. Pardon me for a second. There we go. Get that out of the way. Having some technical issues here. We still need to figure out the French silk. So I'm going to go back. Either of my first equations. I'll just keep using the top one because for some reason I just like doing that. So 11F plus 6. Ooh, I know what C is though. It's 16. I know how much a chocolate one costs. So 11F, 6 times 16 is 96. Subtract that 96 over, which would be 165, and divide by 11. And I know how much the French silks cost. Okay? Those are all of them that I'm going to do. You've got kind of some examples. The examples are completed on yours. Do a good job on this. We're going to see some more story problems set up like this tomorrow. So, see you later.